So this is section 5.5, which is really just a continuation of section 5.4. In section 5.4, we learned how to find different features in the graph of a fraction. And in section 5.5, we're going to re-find all those features, and then we're going to actually sketch a graph of the fraction displaying those features. And quite honestly, the only thing that's new to this section we're going to use our calculator for. To sketch a graph with any accuracy, you need a bit of calculus, and since we're not doing calculus, we're just going to use our calculator to get the accuracy part. So let me just kind of jump into problem 2. Problem 2 gives me a fraction and then asks me to find a few features of the graph of that fraction and just some generic features in general. So for 2a, I'm asked to find the domain of the fraction f of x equals 4x minus 12 over 2x plus 2. And remember, when we find the domain of a fraction, we ignore the numerator and we solve the denominator equal to 0. When I solve this fraction's denominator equal to 0, I need to do 2 steps. I'm going to minus 2 from both sides, and then I'm going to divide both sides by 2, and that will give me x equal to negative 1. X equal to negative 1, the algebra for finding the domain of a fraction gives you the vertical asymptote, but it doesn't give you the domain. For the answer for the domain of number 2, I'm going to say the domain of the fraction f of x equals to 4x minus 12 over 2x plus 2 is all real numbers except, and the algebra came up with negative 1, so I'm going to say except negative 1. For the vertical asymptote part of number 2, it's just going to be x equal to negative 1. It comes right up in the algebra for the domain. There's no extra algebra to do. Now I'm going to show that feature on my graph. I've put a graph down on my problem 2. When you go to do your problem 1, you're going to want to make your x's go between really negative 30 and 30, and y's go between negative 10 and 10. That really surprises me. Let me just check that out real quickly before I get too far into this to make sure that window makes sense for yours. It's kind of shocking to me right now that would be a window that I'd want for yours. I'm going to do number 1 quickly with a zoom standard and see what the graph looks like. Oh, I can see. I don't see much of the graph over here. So when you go to do your problem 1, you want to use x min of negative 30, x max of 30, y min of negative 10, y max of 10, so that when you graph it, you can see all the features of the graph. So for each of your problems, I'm going to tell you the window to use. For each of my problems, the window is going to be kind of implied. My x min is supposed to be negative 10, my x max is supposed to be 10, my y min negative 10, while my y max 10. I haven't got to the graphing part just yet, but that just kind of surprised me. So I'm going to show the vertical asymptote real quickly by putting a dashed line through negative 1 on the x-axis, and it has to be a vertical line. So this is my vertical asymptote of x equal negative 1. For part B, part C is a horizontal asymptote, and to do a horizontal asymptote, I look at the highest x power term in the numerator and the highest x power term in the denominator. The highest x power term in the numerator is a 4x to the first. The highest x power term in the denominator is a 2x to the first. When their highest exponent term in the numerator equals the highest exponent term in the denominator, you divide the coefficients to get the horizontal asymptote. So the horizontal asymptote for problem 2 is going to be y equals 2, and I'm going to divide the coefficients of 4 and 2 here, and that's going to simplify to y equal to 2. So my answer to part C of number 2 is a horizontal asymptote has the equation of y equal to 2, and I'm going to show that on my graph by finding 2 on the y-axis and drawing a dashed horizontal line through 2 on the y-axis. So here's my horizontal asymptote of y equal to 2. For part D, I need to find the x-intercepts. X-intercepts are reasonably easy to find. The easiest way to find the x-intercept is to set the numerator equal to 0, and that's what I'm going to do. So for part D, I could set the whole fraction equal to 0 by going 4x minus 12 over 2x plus 2 equal to 0. Or if you want, you could just set the numerator equal to 0. Both strategies will give me my x-intercept the same way. If I do it this way, I have to write this as 4x minus 12 over 2x plus 2. I have to write it equal to 0 over 1. And then I have to cross multiply. I'm going to cross multiply down and get 1 times 4x minus 12. Cross multiply up and get 0 times 2x plus 2. And that's going to give me 4x minus 12 equals to 0, which is exactly what I've gotten if I would have just set the numerator equal to 0. It's a heck of a lot quicker to set the numerator equal to 0, and you get the same answer. So when I go to find the x-intercepts of my fractions, what I should do is just set the numerator equal to 0 and ignore the denominator. For this problem, the algebra, regardless of which algebra I go through completely with, is going to give me x equal to 3 for the x-intercept. When I go to write my answer for the x-intercept, the opposite letter is always 0. The opposite of x is y. My x-intercept is going to be the point 30. I'm going to write that on my front sheet and put that point on my graph. So my x-intercept is going to be the point 30. And I'm going to graph it. I'm going to make a dot at the point 30. I could write 3, 0 there, but it's going to make my graph kind of messy if I do it. So I'm just going to make a dot for the x-intercept. The last algebra I need to do is find the y-intercept, and that's real easy to do. For part E of 2, I'm just going to find out what f of 0 is by plugging in 0 for the x's. I'm going to go 4 times 0 minus 12 over 2 times 0 plus 2. The pieces with the 0 cancel, and you get f of 0 equals to negative 12 over 2, which is negative 6. That's the y part of the y-intercept. When I go to write the answer, the y part of the y-intercept is negative 6. The other letter, which in this case is x, is always 0. I'm going to plot that point 0, negative 6 on my y-axis. And the rest of what I'm going to do is sketching a graph. All I'm going to do is now set the window that's implied by the graph, or set the window that I tell you, and enter this function and graph it, and make sure that the graph follows the features, meaning make sure that it goes through the x and the y-intercepts, make sure that it's drawn to the asymptotes the same way that your calculator does. So when I go to graph number 2, I'm just going to enter the function y equals parentheses 4x minus 12 divided by parentheses 2x plus 2. My window's a standard window, so I'm just going to do zoom standard. And it's going to sketch a graph. The thing that's going to be important, let me draw the asymptotes in too real quickly. To get the asymptote at x equal to negative 1, I have to take 1,000 times the denominator to do that. So if I go y equals and go 1,000 times the denominator, because setting that denominator equal to 0 gave me the vertical asymptote at negative 1. Doing that now is going to add the vertical asymptote to the graph. To put the horizontal asymptote on the graph, I'll hit y equals and just go down to number 3 and type y equal to 2. Now it's going to throw the horizontal asymptote. Now I'm going to sketch a graph. This upper left-hand quadrant of the graph doesn't have any points to go through, so I'm just going to draw something that looks like this. That's just above the horizontal asymptote. That's just to the left of the vertical asymptote. So in this corner, I'm going to write something that looks like that. I'm going to put little arrows to mean it keeps going up and over. And in the right-hand corner of this, the graph has to go through the x-intercept, and it gets close to that horizontal asymptote. it has to go through the y-intercept, and it crosses the y-axis, and it's going to get close to the vertical asymptote. So I just kind of borrowed best I could from my calculator. My calculator shows me that the graph crosses the y-axis at the y-intercept, and it starts slowly getting close to that vertical asymptote. So this would be a reasonable picture, the best I can do just by copying from what my calculator gave me. That should motivate you hopefully to do problem 1. I'll move on and work my way to problem 4. My window for problem 4 is going to be x min -5, x max 5, y min -18, y max 18, whereas this is your window for problem 3. So let me do number 4. First thing I want to do is find the domain. To find the domain for number 4, which is going to be 4a, I ignore the numerator and I set the denominator equal to 0. To find the domain of any fraction, we set the denominator equal to 0. And in this case, there's some factoring to do. Once I get the denominator factored, I'm going to set each of the factors equal to 0 and get x equal to -1 and x equal to 1. For my domain, I can say the domain of the fraction f of x equals 9x squared minus 4 over x squared minus 1 is all real numbers except plus or minus 1, or I can write 1 and -1. When I go to do part B, the work for the vertical for the domain gives me the actual equations of the vertical asymptotes. My answer to part B, I'm going to have a vertical asymptote at x equal -1 and a vertical asymptote at x equal to 1. If I want to graph these on my calculator, in y2 to get this vertical asymptote, I'm going to enter 1,000 times x plus 1 to get the vertical asymptote at x equal -1. To get that vertical asymptote in y3, I'm going to enter 1,000 times x minus 1. Let me get those in so I can have my vertical asymptotes drawn real quickly without even graphing the function yet. So let me y equals, clear out all the stuff that's in there. In y2, put 1,000 times x plus 1, which is going to be a vertical line that goes through -1. And in y3, put 1,000 times x minus 1, which is going to be a vertical asymptote through 1. When I hit graph, I'm not going to see the fraction graph. There's my vertical asymptote at -1. There's my vertical asymptote at 1 already drawn in. Done with 4a and 4b, have those on my graph on my calculator. Now my by hand graph, I'm going to draw a dashed line through -1 on the x-axis and a dashed vertical line through +1 on the x-axis. So here's my vertical asymptote at x equal -1. And here's my vertical asymptote at x equal 1. Horizontal asymptotes are easy for me, so to do part C, for the horizontal asymptote, I look at the highest exponent term in the numerator and the highest exponent term in the denominator. The highest exponent term in the numerator is the 9x squared. The highest exponent term in the denominator is 1x squared. When there's a tie between the highest exponents, the horizontal asymptote has the equation that you get by you dividing the coefficients of the highest exponent terms. For me, my horizontal asymptote is going to have an equation of y equal to 9. So for my horizontal asymptote, it's going to be y equal to 9. To graph this on my graph, I'm going to find 9 on the y-axis, which I had to estimate, and I'm going to draw a horizontal line through it. So I get a horizontal asymptote at y equal to 9. On my calculator, I'm going to hit my y equals. I'm going to go all the way down to y4. I'm going to type the number 9 and hit enter. And now my calculator is going to draw that line through 9. I haven't changed my window yet, so it looks like it's extremely at the top of the window, but I'll fix that in a bit when I do a little bit more graphing. So done with domain, vertical asymptote, horizontal asymptote. For the X intercepts, the easiest way to find the X intercept is just to set the numerator equal to 0 and to ignore the denominator. So when I go to do part 4D, the easiest way to find the X intercept is just to set the numerator equal to 0. So I'm going to get 9x squared minus 4 equal to 0. I'm going to factor this into 3x plus 2 times 3x minus 2 equal to 0. Then I'll go 3x plus 2 equal to 0, 3x minus 2 equal to 0. This one I'll minus 2 from both sides and get 3x equal to minus 2. Then I'll divide both sides by 3 and get x equal minus 2/3. This one I'll add 2 to both sides and get 3x equal to 2, and then divide both sides by 3 and get x equal to 2/3. I'm going to write these as points, and always the opposite letter is 0, so that the opposite letter of x is y, so the y is going to be 0. My answer to 4D is going to be able to have those two x-intercepts of negative 2/3 and positive 2/3, 0. So my x-intercepts are going to be negative 2/3, comma 0, positive 2/3, comma 0. I'm going to try to estimate those. 2/3 is just a little bit to the left of the 1 and a little bit to the right of the negative 1. So I'm just making dots for the negative and positive 2/3, not writing the point, because that point gets really ugly if I start writing it down. For 4E, the last algebra I need to do is find the y-intercepts. And you find the y-intercepts by plugging in 0 for x. So I'm going to go 9 times 0 squared minus 4 over 0 squared minus 1. These pieces with the 0 cancel out and become zeros. And that's going to leave me with negative 4 over negative 1, which is positive 4. That's the y part of the y-intercept. The opposite letter is always 0. The opposite letter of y is x, so the x is going to be 0. The y-intercept I'm going to plot on the y-axis, that's the point 0, 4. That's everything I can do by hand. I'm going to enter this function in my y1, just this part of the function. I'm going to change my window to almost your window, except my y-min and y-max are going to be the 18s. And then I'll borrow the graph. So let me get this function in. So y1 equals parentheses 9x squared minus 4 divided by x squared minus 1. Have the function in, make my window negative 5 to 5 on the x's, because that's what's marked on my axes, and negative 18 to 18 on the y's, because that's what's marked on my y-axes. I'm going to hit a graph, and I'm going to copy everything the best I can. So my calculator draws the graphs, and it draws the asymptotes in for me. So in this upper right-hand corner, I'm going to enter this little swoosh here. So I'm just going to enter this. I've got no points to go through, so I'm just kind of loosely drawing that. In the middle, I have this parabola, and that parabola needs to go through the x and the y-intercepts. So I'm going to just draw this parabola just like it looks on my calculator, or as close as I can make it look on my calculator for the middle section. And then the upper section, I don't have any points to go through, but it's just, again, kind of this swoosh stays above the, it stays to the right of the vertical asymptote, it stays above the horizontal asymptote. So that seems like a reasonable graph. If I look at my calculator's graph and what I sketched by hand, that's as close as I'm ever going to get a graph, so that's about as good as it gets, and I'll just stop it right there. You can give number 3 a go, and I'll move on to do number 6. So for number 6, part A, I'm going to find the domain. To find the domain of any fraction, you take the denominator equal to 0. And for this one, I'm going to solve for x by dividing both sides by 3. On the left side, the 3's cancel, I get an x. On the right side, I get a fraction with a 0 in the numerator. So that simplifies to 0. I'm going to say the domain of the fraction f of x equals 4 over 3x is all real numbers except x equal to 0. The vertical asymptote always comes from the algebra from the domain, so my vertical asymptote is going to be x equal to 0. And x equal to 0 is really unfortunate because x equal any equation that just has an x as a vertical line, and x equals 0 actually goes through the y-axis. So this equation, x equals 0, is actually the y-axis. And I can't really graph that on my calculator because my calculator already draws the y-axis. I won't see anything. So I'm not going to enter this as a separate function because the y-axis is already going to be drawn for me. To do the horizontal asymptote for 6C, I probably can think of this problem, instead of thinking it as 4 over 3x, I can think of it as 4x to the 0 over 3x to the 1, because 4x to the 0 is 4 times 1, because x to the 0 is 1. And the bigger exponent is in the denominator. And when the bigger exponent is in the denominator, there's no algebra to do. The x-axis is the horizontal asymptote, which has an equation of y equal to 0. And that's what the top of this says. If the exponent in the exponent in the numerator is less than the highest exponent in the denominator, you get y equal to 0, or the x-axis, for your horizontal asymptote. So there's no algebra to do for the horizontal asymptote. The equation is going to be y equal to 0, which is the x-axis. And this is another thing that I'm probably not going to graph on my calculator, because my calculator is going to draw the x-axis already. So my initial bit of graphing was the vertical asymptote at x equals 0. My second bit of graphing is my horizontal asymptote at y equal to 0. Now I'm going to move on to 6D and find the x-intercepts. The easiest way to find an x-intercept of a fraction is to take the numerator and set it equal to 0. Here there's no x. Because there's no x and I have a false statement, there's no solution to this because I can't isolate an x. There's no solution to that problem. That means there's no x-intercept. For part 6e, when I go to find the y-intercept, I go f of 0 equals 4 over 3 times 0, which is going to be 4 over 0. And any fraction with a 0 in the denominator is undefined. Because I got undefined when I try to get the y-intercept, there's also no y-intercept. So there's not a lot to plot here. I don't need to do separate graphs for the vertical or horizontal asymptote because they're on the x's, which were already drawn. And there aren't any x or y-intercepts, so there's none of those to plot. So when I go to graph this, I'm just going to make my window go from -5 to 5 on the x's, -3 to 3 on the y's. I'm going to enter this function, and I'm going to copy it the best I can. So y equals, I'm going to clear out anything that I already have in there because they're not going to do me any good. I'm going to enter 4 divided by, and I better put the entire denominator in a parentheses. And I'm going to set my window for x min -5, x max 5, y min -3, y max 3. I'm going to hit my graph, and I'm just going to draw the portions. The bottom left-hand portion looks something like this, gets drawn to the asymptotes. And the upper right-hand portion looks like this, it gets drawn to the asymptote. So I'm not doing anything particularly algebraic or mathematical. I'm just copying the graph the best I can, making sure it gets drawn to the vertical and the horizontal asymptotes that I've drawn in. So this is the best I can do for number 6. There weren't any intercepts to plot. I darkened out the axes and told you that they were the asymptotes as well. All right, so give number 5 a go. We'll move on to do 7 and 8, and we'll get a video break in between this. A bit more algebra for number 7. So to do the domain for number 7 or 8, can I do number 7 for you? I'll do number 8. So for number 8, part A, when I go to find the domain, I ignore the numerator of x minus 1, and I solve the denominator equal to 0. I'm going to solve this by factoring. That factors into x plus 6 times x minus 2. I'll set the x plus 6 equal to 0 and the x minus 2 equal to 0. That will give me x equal to -6 and x equal to 2. So I'm going to be lazy because I don't know how much of this I can fit in here. I'm going to say the domain is all real numbers except -6 and 2. I could have said the domain of f of x equals to x minus 1 over x squared plus 4x minus 12 is that, but I got lazy and didn't include the function, and that's completely okay to do. We don't have to every time write the function in that answer. The algebra gives me the vertical asymptote, so there's going to be a vertical asymptote at x equal to -6 and a vertical asymptote at x equal to 2. To get these on my calculator, in Y2, I'm going to draw 1,000 times x plus 6. And in Y3, I'm going to enter 1,000 times x minus 2. Those are the factors that produce those vertical asymptotes. Let me get these on my calculator really quickly. So clear out. So 1,000 times x plus 6. I'll worry about the windows in a bit. And 1,000 times x minus 2. When I hit graph, I'm going to get vertical lines that go through 6. And I'm not going to see that vertical line because my window's no good. Let me tweak my window to go from -10 to 10 on the x's like I suggested. And -3 to 3 on the y's. Now I'll see my vertical asymptote at -6 and my vertical asymptote at 2. So my vertical asymptotes are on my calculator, not on my paper. Let me get them on my paper real quickly by going through -6 on the x-axis and drawing a vertical line, and going through +2 on the x-axis and drawing a dashed vertical line. So this is my vertical asymptote at x equal to -6 and my vertical asymptote at x equal to 2. For part C, to move on to my horizontal asymptote, I look at the highest power term in the numerator compared to the highest power term in the denominator. The highest power term in the numerator is an x to the first. The highest power term in the denominator is an x squared. When the highest exponent in the numerator is less than the highest exponent in the denominator, the x-axis is the horizontal asymptote, which has an equation of y equal to 0. There's no algebra. This is just a fact I need to know. So the horizontal asymptote is going to be y equal to 0. That's the x-axis. So I don't really need to draw that on my calculator because my calculator is going to draw the x-axis already. But by hand, I can emphasize that this is my horizontal asymptote of y equal to 0. To do part D, the X intercepts, it's enough just to set the numerator equal to 0. So I'll go x minus 1 equal to 0. I'll get x equal to 1. The X intercept's going to be the point 1, 0. And my X intercept's going to be right on a horizontal asymptote. That's okay. Graphs can cross horizontal asymptotes kind of by the origin. They can never cross a vertical asymptote. The horizontal asymptote only impacts the graph to the far left and the far right edge. It doesn't impact the graph by the origin. To find the y-intercept, I'm going to plug 0 in for all these x's. So I'm going to go f of 0 equals 0 minus 1 over 0 squared plus 4 times 0 minus 12. All the pieces with 0 disappear, and I'm left with minus 1 over minus 12. And that simplifies to positive 1/12. That's the y part of the y-intercept. The opposite letter, x, is going to be 0. So the y-intercept is going to be the point 0, 1/12. And that's just hovering right above the origin. It's just slightly above the origin on the y-axis. Now I'm going to sketch a graph. I have everything labeled from my parts 8 through E. I didn't do the domain that showed up as a vertical asymptote. And now I'm going to graph this function with the window that I picked. So in my y1, I'm going to go x minus 1 in parentheses divided by x squared plus 4x minus 12 in parentheses. When I hit graph, it's going to give me pieces. The bottom left piece I'm going to make look like it does, like this. The middle piece is a little squiggle. It goes through the y-intercept, it goes through the x-intercept, and it gets down really close to this vertical line. Doesn't cross it, the vertical line, at all. So I'm going to just draw this so it looks to me like it starts up here, goes through the y-intercept, goes through the x-intercept, then it gets really close to that vertical asymptote. And in the upper right-hand corner, I get something that's really close to the vertical asymptote and really close to the horizontal asymptote. My graphs aren't going to ever cross vertical asymptotes, and if they cross a horizontal asymptote, it's going to be close to the origin. Once we get out far enough from the origin, the graph is just going to stabilize and not jump the horizontal asymptotes. So that's a reasonable graph. It looks enough like what my calculator gave me that I feel okay about it. All right, so give 7 a go. 9's kind of messy, and I'm going to do 9 for you. Messy on a lot of fronts. Messy on I need a bizarre window. Problems 9 and 10 are tough. Not the kind of thing that I'd probably ask on a test. Let me do number 9 for you. I have a really big window, -50 to 50 on the x's, -50 to 50 on the y's. Let me start off with number 9, part A, to do the domain. To find the domain of any fraction, it's enough just to take the denominator and set it equal to 0. So I'm taking the denominator of x minus 5 and set it equal to 0, and I'll get x equal to 5. So for number 9 for the domain, I'm going to say the domain is all real numbers except 5. For the vertical asymptote, it's going to be x equal to 5. And to graph the vertical asymptote, I'm going to do 1,000 times x minus 5. I'm going to put that in y1. So I might as well get my window set up on the 50s and get this vertical asymptote in there real quickly. So my window is supposed to be x min negative 50, x max 50, y min negative 50, y max 50. And in the y2, not y1, I'm going to enter 1,000 times x minus 5. So y equals y2, 1,000 times x minus 5. Just to draw that vertical asymptote for me right off to the right of the origin. So that's, I'm going to put this on my graph real quickly here. So right through 5 on the x-axis, I'll draw a vertical asymptote. This one's going to have a slant asymptote because when I look at the terms in the numerator for part C, the highest power term in the numerator is x squared. The highest power term in the denominator is x to the first. When the numerator has the largest exponent, you don't get a horizontal asymptote, you get a slant asymptote, which I don't generally ask on the test. It's going to have the equation y equal x squared over x when this is reduced. X squared over x reduces real nicely. The numerator, I can write it without the exponent, and I get x times x over x. I can cancel and get y equal to x for my slant asymptote. So the answer to part C is there's a slant asymptote at y equal to x. Y equal to x goes through the point 0, 0, 10, 10, 20, 20, 30, 30, 40, 40, 50, 50, negative 10, negative 10, negative 20, negative 20. For y equal to x, it goes through any point where the x and the y are the same. So let me draw this in. I'm going to do it on my calculator, but the easiest way to draw the line y equals x by hand is just label any points that have matching x's and y's. 1, 1, 2, 2, 3, 3, but in this case 10, 10, 20, 20, 30, 30. On my calculator, into my y3, I'm just going to type the function x, and it's going to graph that slant asymptote for me. Now I'm going to find the x-intercepts. To find the x-intercepts in part D, I set the numerator equal to 0. That gives me x squared equal to 0, which is x times x equal to 0. So I go x equal to 0 and x equal to 0, setting each one of these factors equal to 0. The x-intercept is just going to be 0. This actually has even multiplicity, so at the x-intercept, the graph is going to touch but not cross the x-axis. The x-intercept is going to be the point 0, 0. For part E, the y-intercept, I plug 0 in for x. I'm going to get f of 0 equals 0 squared over 0 minus 5. That's going to be 0 over minus 5, and that's equal to 0. So the y-intercept is also going to be 0, 0. This is everything I can graph from parts A, B, C, and D, and E. For B, C, D, and E, really A I don't graph. Now I'm going to enter this on my calculator and hope the window that I selected is reasonable. So I'm going to go y equals x squared divided by parentheses x minus 5, hit my graph button, and looks good. So in the upper right-hand corner, the graph gets close to the vertical asymptote and it tracks the slant asymptote. So this corner looks something like this. I don't have any points that I have to go through, so it looks something like that. And in the bottom, the graph tracks this vertical asymptote. What it does is it gets to the intercept. Since it's an even multiplicity, it doesn't cross the x-axis. It bounces off the x-axis and comes back down and tracks that line. So that's the best I can do in terms of kind of copying from my calculator this graph, the best I could anyways. And again, I'm not looking for perfection on the sketching the graph here, so just something that's reasonably okay. And that's your problem 9 done, so you don't even have to do that except copy that into your notes for me. So I'm going to move on and do problem 12. You can do problem 11. It's another slant asymptote problem. For part 12a, to find the domain of my fraction, I set the denominator equal to 0. So I'm going to do 12x minus 4 equal to 0. I'm going to add 4 to both sides and get 12x equal to 4. I'm going to divide both sides by 12 and get x equal to 4/12. I'm going to reduce that fraction and get x equal to 1/3. So my domain is going to be all real numbers except 1/3, or except x equal to 1/3 if you want. Means I'm going to have a vertical asymptote at x equal to 1/3, and x equal to 1/3 is just to the right of the origin, or just to the right of the y-axis, not quite halfway between the 0 and the 1. So here's my vertical asymptote at x equal to 1/3. So that's for part B. On my calculator, if I just graph into y2, 1,000 times 12x minus 4, that will give me the vertical asymptote at 1/3. Let me get that in there real quickly. Let me get my window okay. My window is -3 to 3 on the x's and -5 to 5 on the y's. And my vertical asymptote in y2 is going to be 1,000 times 12x minus 4. Let me clear all this stuff out of here. So 1,000 times 12x minus 4. When I graph it, I'm going to get that line that goes through 1/3 that I just drew. This one's going to have a slant asymptote. When I go to do part 12c, I take the highest exponent term in the numerator, which is 3x squared, divide it by the highest x power term in the denominator. When the biggest exponent in the numerator is bigger than the biggest exponent in the denominator, you get a slant asymptote, and you need to reduce this fraction. This fraction is easy to reduce. I can write the 3x squared as 3 times x and reduce an x. And the 3 over 12 reduces to 1/4. So for my slant asymptote, I can write this as 1x over 4, or I can write it as 1/4 x. So however you feel comfortable writing it, you can write it. When I go to enter this on my calculator to get it to graph, I'm going to go y equals, and in y3, I'm going to do 1/4 in a parenthesis, so 1 divided by 4 in a parenthesis, and then times x, and it'll draw that slanted line for me. If I'm graphing it by hand on my graph, I'm going to use the slope in the y-intercept. This is really 1/4 x plus 0, so I'm going to plot 0 on the y-axis. The slope is 1 over 4, so I'm going to go up 1 and right 1, 2, 3, 4 to get my next point. So using the slope of 1 over 4, up 1, right 4, and the y-intercept of 0 that I haven't found yet to get a decent graph of that slant asymptote. So there's the slant asymptote, but it looks a lot like my calculator slant asymptote. All right, part D, to find the X intercepts. I'll pull out another sheet of paper. So for part D, to find the X intercept of a fraction, it's enough to set the numerator equal to 0. For this one, I'm going to divide both sides by 3. That's going to give me x squared equals to 0. That's really x times x equal to 0. I can set each of these factors equal to 0. They both give me the answer x equal to 0. It has even multiplicity, so the graph is going to touch but not cross the x-axis at 0, 0. The x-coordinate of the x-intercept is 0. The opposite letter, the y-coordinate, is also going to be 0. That's a point that I already marked on the graph. For the y-intercept, I plug 0 in for all these x's. So for 12e, for the y-intercept, I'm going to do 3 times 0 squared over 12 times 0 minus 4. That's going to be 0 over minus 4, which is 0, because the pieces with a 0 turn into zeros. And I have a fraction with a 0 in the numerator, which is equal to 0. That's the y part of the y-intercept. The x part is also 0, so the y-intercept is also going to be 0, 0. Done all the algebra I could do. Now it's just copying in from my calculator and entering the problem properly. So now I go y equals, and I do 3x squared divided by parentheses 12x minus 4. Graph it and just try to copy. And boy, it's getting tough to see. In this upper corner here, the graph is so close to both lines that you can barely distinguish it. So in this upper corner, the graph gets super close to that line, turns away a little, and gets super close to that line. So this is the upper corner. Let me shut this graph off and have it regraph it so you can watch it graph it real quickly. There's the vertical and the horizontal asymptotes. Now I'm going to turn this back on and watch the graph that upper right hand corner. It's just hugging that. Similarly, in the bottom left hand corner, it gets really close to the asymptote. It gets up to the x-intercept. It bounces off the x-intercept. Then it hugs this line, I think, slightly above the line. So I think it does this. It hugs the vertical line, gets to the x-intercept, and it doesn't cross the x-axis. It bounces off the x-axis, and then it stays really close to that line. So it's pretty tough to draw these. Part of the reason I don't ask these on the test ever, unless you two do a makeup test. In the makeup test, I make a little bit harder than the regular test. You might get one of those. So the last problems, 9, 10, 11, and 12, I do because I have to do them, but they won't be on a test. These next problems are definitely test worthy. So for 14, to find the domain, I'm going to set the denominator equal to 0. So for 14a, I set the denominator equal to 0. I get x equal to negative 5. I'm going to say the domain is all real numbers except negative 5. My vertical asymptote is going to be x equal to negative 5. Let me get that graphed by doing 1,000 and y2, doing 1,000 times x plus 5. Set my window to be on the 20s on the x's, on the 10s on the y's. Yours has to go from the 15s on the x's and the 10s on the y's when you graph yours. So for my problem 14, I'm going to clear out all the crud that's in here. I'm going to enter 1,000 times x plus 5 for my vertical asymptote at negative 5. I'm going to make my window negative 20 to 20 on the x's and negative 10 to 10 on the y's, just because I did that work ahead of time to know what the window should be. Now I'm going to graph this vertical asymptote at x equal to negative 5 on my graph as well. So my vertical asymptote goes through x equal negative 5. For part C, to do the horizontal or vertical asymptote, the highest exponent term in the numerator is a 2x to the first. The highest exponent term in the denominator is a 1x to the first. When there's a tie, you just find a horizontal asymptote. There's a horizontal asymptote, and you get it by dividing the coefficients. That's the middle of my three cases. If there's a tie between the exponents, you divide the coefficients, and that's going to give me y equal to 2 for my horizontal asymptote, which I'm going to graph on my calculator here in a second. So my horizontal asymptote is y equal to 2. Let me graph that, put that in my y3, and graph it. For the x-intercepts in part D, the easiest thing to do is just to set the numerator equal to 0. So I'm going to go 2x minus 10 equal to 0, add 10 to both sides and get 2x equal to 10, divide both sides by 2 and get x equal to 10 over 2, which is x equal to 5. That's the x part of the x-intercept. The opposite letter is always 0, so the y is 0. I'm going to mark that point on my graph. Lastly, I'm going to find the y-intercepts by plugging in 0 for x. So when I go to do 14e, I'm going to do f of 0 equals 2 times 0 minus 10 over 0 plus 5. That's going to simplify to minus 10 over 5 because the 0 pieces go away, and minus 10 over 5 is negative 2. So my y-intercept is going to be the point 0, negative 2. And now I'm going to graph this, borrow my calculator's graph. So on my calculator now, I'm going to enter the function in y1, 2x minus 10 divided by x plus 5, and make sure I make my graph go through the intercepts and look like it should look. So in the upper right left-hand corner, it looks something like that. In the bottom left, it goes through the x and the y-intercept, and it gets drawn to the asymptote. So it looks something like that. So again, I'm just borrowing my calculator's work, and I'm not trying to improve upon my calculator at all. Make sure my graph goes through the intercepts and just goes closer to the asymptotes, as close to the asymptotes as it should. So give 13 a go. We just have 2 more problems to do each. And they're so easy, they're hard. Sometimes I put these on the test because I think they're easy. For 16a, to find the domain, I set the denominator equal to 0, and I get x equal to 0. So the domain is going to be all real numbers, except x equal to 0, which means there's going to be a vertical asymptote at x equal to 0, and x equals 0 is the y-axis. So I don't have to draw that on my calculator, it'll already be done. For 16c, I probably should think of this as 3x to the 0 over x to the first power. And that will make the highest exponent be in the denominator. When the highest exponent is in the denominator, the x-axis, or y equal to 0, is the horizontal asymptote, and there's no work to do. So the horizontal asymptote is going to be y equal to 0, and there's no work to do for that either. And there's nothing to draw on my calculator, because my calculator already draws that axis. For the x-intercept in part D, I set the numerator equal to 0. Because there's no x, and that's a false statement, there's no x-intercept. For part E, I plug in 0 for x. I get a fraction with a 0 in the denominator, which is undefined. And when you get undefined when you're trying to find an intercept, there's none of those either. So there's not a lot to put on this graph. I have the asymptotes on, but they're already the axes, and there aren't any intercepts. So now I'm going to set my window to -8 to 8 and -5 to 5 and copy my calculator's graph. So clear out all this stuff that's in there. I'm entering the function 3 divided by x. I don't need parentheses because those are all monomials. And I'm going to go -8 to 8 for the x's, -5 to 5 for the y's, hit my graph button, and copy the best I can. So I have a bottom left that looks something like that, and an upper right that looks something like this. And I'm not looking for perfection here, just something that vaguely represents the graph that looks similar to your calculator's graph is good enough, as long as it goes towards the asymptotes that you've drawn in, and if there's any intercepts, if it goes through the intercepts. So you can do 15, and now let me do your 17 just to get this done. So last problem, 17 and 18, I'll do 17 to help you out. So 17a, to find the domain, I set the denominator equal to 0. That's setting x squared equal to 0. That's really setting x times x equal to 0. I can take each of the x's and set them equal to 0, and I still get x equal to 0 for problem 17a. So the domain is going to be all real numbers, except x equal to 0. The vertical asymptote is going to be at x equals 0, which is actually the y-axis. So my vertical asymptote at x equals 0 is the y-axis. For the horizontal asymptote, the highest exponent in the numerator is x to the first. The highest exponent in the denominator is x squared. When the exponent in the denominator is bigger than the highest exponent in the numerator, the horizontal asymptote is y equal to 0, which is the x-axis. That's the top of my 3 cases, and there's no work to do for that either. So here I get a horizontal asymptote at y equal to 0. For part D, to find the x-intercept, I just take the numerator and set it equal to 0. This is going to give me x equal to -5. My x-intercept is going to be the point -5, 0, which happens to be right on a horizontal asymptote. My graph's allowed to cross a horizontal asymptote kind of close to the origin. And for part F, I'm going to put 0 in for the x's. For part E, to find the y-intercept, I'm going to put 0 in for the x's. I'm going to get f of 0 is 0 plus 5 over 0 squared. That's going to be 5 over 0, which is undefined. And when you get undefined, you don't have that particular x-intercept. Not a lot to graph here. The x and the y-axis are already drawn, and I'm just going to graph this function with the window. So I need to set my window from -10 to 10 on the x's, -10 to 10 on the x's, and -3 to 3 on the y's, because that's what I suggested. I'm going to enter the function x plus 5 divided by x squared. I put the x plus 5 in a parentheses because it's a binomial. The x squared doesn't really need to go in a parentheses. Hit my graph button, and the upper right-hand corner is easy to draw. The upper right-hand corner just looks something like that. The left is a little bit harder. What happens with the left at the x-intercept is because the x-intercept had odd multiplicity, the graph is going to cross the x-axis there, and then it's going to get drawn back to the vertical asymptote. So it doesn't bounce off the x-axis, it crosses it because the factor that made it had odd multiplicity. So my calculator kind of is doing that. You can barely see it. The graph crosses at -5, 0, and then it stays so close to the x-axis that you really can't see it the rest of the way. All right, so that's got to be a good stopping point. So let's end this. We just have one more section of new material, and then we get the Chapter 5 test.